In this video, we'll discuss torch vision models. So there's two ways you can use a torch vision model. And you can create a pre-built model by calling the constructor just like your own model. But the problem with these models is the weights are randomly initialized, and half the battle with these models is actually training them. So in this section, we're going to focus on calling a pre-trained model. So what we're going to do in this section is we're just going to focus on pre-trained models, and pre-trained models can get pretty complicated in itself. So we're going to do what I find the simplest, and we're going to basically retrain the final output layer of our neural network, and then all the layers preceding that layer will be a pre-trained model that's been pre-trained with lots of data. And what usually happens is you get better results on your data set. So from torchvision.models, you import models. In this example, we'll use ResNet 18, and we'll set the parameter pre-trained equal to true. And ResNet is basically a deeper network. There's other models. Everybody's favorite AlexNet is also included. So depending on what model you used, you're going to have to do the appropriate transform. So for ResNet, this is the particular transform. You have to make sure the size and normalization parameters are the same. And we'll have a training set and validation set we'll use. And this can be anything you want, but it has to basically be a colored image. And we have to make sure it has a proper input for ResNet. So basically, all we're going to do in a pre-trained model, this is the last hidden layer of a fully connected neural network. So we're going to set all the parameters to our model. We'll set the parameters required grad equal false. And if you remember back in section 1.2, when we set the parameters required grad equal to true, the model was differentiable. So now we're actually doing the opposite. So we'll create another fully connected layer. And in this case, we're going to have three classes noted by this parameter over here. 512 will be the number of inputs from our hidden layer. And then we'll create a loss function. And then for our optimizer, the only thing we're going to adjust is we're going to only optimize the parameters where requires grad equals to true. And you can use any optimizer. So we'll create a training loader and a validation loader. And we'll train our model just like before. But just a note, in many models, including ResNet, we'll have to set it to train and evaluate. And this can take a long time, even though it's pre-trained, because these models are pretty large. So that's it for pre-trained models.